C++ arrays.
Now here we are having one integer array having the name n with 10 consecutive locations, and here the subscript or the location number will be ranging from 0 to 9. So we are executing one for loop, and the for loop is extending from 0 to 9. So int I is equal to 0, I less than 10, so I can get up to 9 only, and I plus plus I will be incremented by 1 always. Ni, that is at the ith location of the n array, I plus 100. So the value of I will be at first will be 0. So 0 plus 100, 100 will be assigned. 1 plus 100, then 101 will be assigned. 2 plus 100, then 102 will be assigned. In this way the values will be assigned accordingly. Set element at location I with I plus 100. So now here we are printing headings, that is the element and value. So if we compile our program, and if I want to show you that how the outputs are coming, so now here you see the element is the respective text. This is a respective text we are having element, and set with 13 we are having this set with 13 characters, and then value, and then endl. So here we are having 13 characters, out of them value is having 5 characters. So here in between we are having 8 characters gap, so that we are having this output in a very columnar way. So for int j is equal to 0, j less than 10, j plus plus, so again the j is ranging from 0 to 9. So cout set with 7, and then we are printing this value j. So here you see we are having this 7 is the width, and then 0 to 9 they are the single digit numbers. So as a result of that we are having 6 blank spaces beforehand, and then numbers are getting printed. And then set 13, again we are denoting, we are having this set with 13 characters, and out of them 3 of them are getting occupied by the 3 digits. So 10 blank spaces beforehand, so they are coming. So set with 13, and nj we are printing this current value of this n array at the jth location, and endl will bring the next line, printing in the next line. So in this way this particular array is getting defined, array has got initialized, then array content is getting printed. So in this way we have explained this program line by line. I think now your conception is getting clear at this particular stage.
C++ bitwise operators.
Let us explain this program and also to show you that how the bitwise operation can be done in C++. So here this value of a is equal to 60, in binary it has been expressed in this way. Value of b is equal to 13, so in binary it has been expressed in this way, and c is equal to 0. Okay, now a and b, so that means I shall be doing the bitwise ANDing. We know that 1 and 1 is 1, and 1 and 0, or 0 and 1, or 0 and 0 will produce output 0. So if you do this bitwise ANDing, I'm getting this 1 1 will survive, and all of the rest bits are getting ANDed with either one of the zeros will be there. So as a result of that, the output will be like this, which is nothing but 12. So if you print the value of c here, so I'll be getting 12 here. So in case of odding, the output will be like this one. The decimal equivalent is 61. So accordingly it will get printed. So 61 is supposed to get printed here. Okay. Now here we are having the respective values, that is a XOR b. So a XOR b means we know that 0 and 1 and 1 and 0, their XOR will be 1. 0s are 0 and 1s are 1, the XOR will be 0 in that case. So similarly, if we do this XORing, so XOR will be denoted by this particular upper caret symbol. So there is a representation of XOR. Okay. Now, so if you do the XORing between this a and b, so then the output will be obtained as like this one. So you just go on doing the XORing, we will be getting this output like this, and that will be 49. So 49 is supposed to get printed here. So here we are doing this complement. Complement means ones complement. So 0011, 1100 will be converted to 1100 and 0011, and which is nothing but minus 61, because here this one will indicate the number is negative, and the respective value will be obtained by taking the 2's complement of that. So it is minus 61. So value will be minus 61. So line 4, the value of c is this. So let me execute the code also side by side. So here we are getting this, that is C is equal to minus 61. Okay, now next one is A. There is a double arrow. This particular double less than symbol will indicate that we are moving this A. All the bits in A will be shifted towards the left hand side. So left shift will take place for 2 bits position. So ultimately we are getting this value, and this value is nothing but 240. And here we are doing this right shift for two places, so here is the respective value whatever we are going to obtain. So if we do the left shift for two places, then in that case 2 bit positions, then in that case these two zeros will disappear. And if we do the right shift for two places, 2 bit places, then these two zeros will be disappearing, and the free space will be filled up with zeros. So as we did here, so it is nothing but 15. So similarly we are getting this output like this. Now let me execute the same code. Now let us execute the same code in our GNU. So G++, program name is prog16.cpp, minus o a.exe will be the output file name. So if I execute the code now after compilation, we are getting the same output which we obtained in case of dep C++ output. So in this way we have explained the execution of this program, and this program is dealing with different types of bitwise operators.
C++ assignment operators.
Let us explain the execution of this program now. Here we are having this int a is equal to 21, int c which is uninitialized, c is equal to a. So let me execute my code so that we can get the idea that how the outputs are obtaining. So I'm executing my code now. So this is the output screen we are getting. So also I'm putting this notepad side by side to do any rough work. Okay, int a is equal to 21 and c is defined but uninitialized. C is equal to a and the value of c has got printed. So c has got printed as 21. C is plus equal to a, that means c is equal to c plus a. So c is having value 21, a is having value 21. So 21 plus 21, 42 will be the new content for c, and that has got printed here. Now c minus equal to a, so 42 minus 21. So c is equal to c minus a, so 42 minus 21, so 21 will be the new value for c. So 21 is coming for the new value for c. Now c star equal to a, so now c is having the value 21 and a is also having the value 21. So 21 into 21, the multiplication is taking place, and that is 441. So in this way you are getting this 441. So now c slash equal to a, that means c is equal to c by a. So that means 21 squared by 21, so that is 441 by 21 is equal to 21 will be the new value for c, and yes, the value of c has got printed as 21. Now c is equal to 200 and c percentage a, percentage is equal to a, that means c is equal to c percentage a. That means the value of 21, this particular value 200 rather, will be divided by 21, and the remainder whatever is getting obtained, and that will be assigned to c. So the value of c has become 11 in that case after doing this remainder operation. So c, there is a left shift equal to 2. So that means that we are going to shift the value of c towards the left hand side for 2 bits place. So we know that 2 bits place left shift means 2 to the power of 2, that is 4 will be multiplied in the resultant value for c. So 11 into 4, so the output will be 44 in that case. So now again we are doing the right shift for 2 places, and as we are doing the right shift for 2 bit places, so that 44 has to be divided by 2 to the power of 2, and that is 2 to the power of 2 means 4. So again we are getting back this 11. Now c and 2, so 11 means we know that if you write 11 in byte form, and that is 8, 4, 1, 2 and 1, so it is 11 is nothing but 8 plus 2 plus 1. So that's why I have placed 8, that means 1 I have placed in the position of 8. So 0 I have placed in the position of 4, and in the position of 2 and 1 I have placed 1 and 1. So now if it is getting ended with the value of 2, so that is 0010, then I'm going to get, after doing this ending, I shall be getting this 2 as a result, so which is nothing but 2. So that's why after doing this AND operation we are getting this 2, and then we are doing this XORing with 2. So we are doing this XORing, so 2 XOR 2, always it will be 0, because similar bits XOR will produce the output 0 in that case. So if we do the XORing between these two, if we do the XOR, then obviously the output will be 0. So similarly I'm getting this value C is equal to 0, and in the last we are doing this ORing with 2. So with this result, if we do the ORing, then obviously the output will be 2 again. So in this way the output has become 2. So in this way we have explained that how the outputs are coming, and the same outputs will be obtained in case of GNU++ if you go on compiling our program in GNU++. So in this way we have explained our code with the proper tracing, that how the values are getting generated.
C++ relational operators.
We are going to execute our code and we shall explain the output line by line. So here we have done the compilation and run. So here we are using dev C++ for the execution of our code. So this is the respective output. So A is equal to 21, B is equal to 10, and C is defined but uninitialized. So A is equal to B is false. So that's why the control will be coming to the else part, and line 1 A is not equal to B. So line 1 A is not equal to B has got printed. Now A less than B, A is equal to 21 and B is equal to 10, so A less than B is false. So the control will be coming to this else part. So line 2, A is not less than B, A is not less than B, so A is not less than B. So the corresponding output has been explained logically. So now if you go for the next part, that means A greater than B, and here it is true because 21 is greater than 10. So line 3, A is greater than B is going to be printed. So line 3, A is greater than B has got printed. So now here we are having A is equal to 5 and B is equal to 20. So now if I go on printing, A is equal to 5 and B is equal to 20. So if A less than equal to B, so A less than equal to B is true. So line 4, A is less than or equal to B. So line 4, A is less than or equal to B. And B is greater than equal to A. Line 5, B is greater than or equal to A. So B is greater than or equal to A. In this way, we are getting this output logically explained.
C++ logical operators.
Now let us explain this program with the execution. Here value of A is non-zero, that is 5, and B is also non-zero, that is 20, and C is uninitialized. So A and B, here we are doing this particular logical operation. So here is a logical operator AND. So A and B, here we are getting the line 1, the condition is true, because here A is non-zero and B is also non-zero. So now non-zero means both are true, so true and true will be true. So the condition is getting satisfied and the output is obtained. So let me execute the code at first so that we can have the better understanding. So let us execute the code in GNU++. So we are having this compiler G++, and then our program name is this one -o. The output file will be say a.exe. So after compilation, if I execute, I'm getting line 1 condition is true. So really I'm getting this line 1 condition is true. A or B, here both A and B are non-zero, so both are true. So true or true will be output will be true. So line 2 condition is true is getting executed. So now A is equal to 0 and B is equal to 10. So A and B will be returning the value 0 here or false here, because 0 means false and non-zero means true. So false and true output will be false. So condition will be going, the control will be going to the else part. So line 4 condition is not true. So line 4 condition is not true. So the output is coming accordingly. And if you take the negation over it, so if we do the complement of that, then we are getting line 5 condition is true. So line 5 condition is true is coming accordingly. So if we do the compilation and if we do the execution in dep C++, we are supposed to get the same output. Really, we are going to get the same output as we got in case of GNU C++ program compilation output. So in this way, the program has been explained.
C++, the hash operators.
In this program, we are going to define the usage of the operator hash. We know that operator hash causes a replacement text token to be converted to a string surrounded by quotes automatically. So here you see, here we have written this mkstr hello C++. So please note that here this hello C++, this particular string is not enclosed within double quotes. So we have defined one macro here. So hash define mkstr x hash x. So that means this particular x is nothing but hello C++ and it will be enclosed within double quotes, and accordingly the output will be obtained. So now let me execute my code. So I have clicked on compile and run option, and now if I execute my code, I'm getting this hello C++. So thus we have explained the usage of operator hash, which is causing a replacement text token to be converted to a string surrounded by quotes.
C++ hash operators.
Here we have defined concat a comma b, a hash b. So in this program, we are supposed to discuss the usage of the operator double hash. And when this concat appears in the program, its arguments are concatenated and used to replace the respective macro. So here we have used this concat x comma y. So now this x and y will be coming down here. So they will get concatenated. So they will become the variable xy. And here we have initialized this variable xy with the value 100. In the similar way, str and 1. So when they will be coming to str and 1 to a and b, then obviously this str and 1 will get concatenated. So as it is hash defined, so preprocessor will come into the play, which will replace this particular part by xy, and which will replace this particular part as str1. So the respective variable xy content will get printed, and respective variable str1 its content will get printed. So preprocessor will come into the play, which will do this macro substitution. That means replacement of this particular macro called by the respective macro body. So now let me execute my code, and I'm expecting 100 and hello world going to get printed as the output of this program. And according to our planning, yes, we have got this 100 and hello world has got printed here. And this is a very good example of uses of hash operators and macro substitution.
C++, the raise function.
In this program, we are going to discuss this function raise. You see, like the previous program, here we have defined one signal handler function, and here is a signal function which requires two arguments. The first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. When the signal will be generated, how to handle the function, how to handle the situation, that will be written in the respective function code. So in this way, we have written this signal handler here. We could have given a separate different name according to our wish to this respective function as well. So now here you see, here this value of I is equal to 0 initially, and this while is not falling in an infinite loop. It is just going for I is equal to I plus 1, that is plus I here we have done. But when this value of I is equal to 3, that means when this value of I is equal to 3, then we are raising sig int. So in this way, when the value of I will be 3, then the signal int will be raised and the corresponding program will halt here. Okay, and each and every time after printing going to sleep once, it will wait for 1 second delay. To have this particular function running, we had to include this respective header file, that is unistd.h. Okay, now let me execute the code at first. So you see, if I execute the code in dep C++,
the output is coming like this one. So interrupt signal 2 received. So here this value of this signum is 2 here. The value of this signum is 2 here. So accordingly it is getting printed.
C++ pointers to structures.
Let us explain this program. So here we have defined one structure variable. The name of the variable is books, and which is having 4 fields. First 3 fields will be of string type, so that's why we have defined character arrays for them, and the last field is of the type integer, which is containing the book ID. Here we have defined 2 structure variables. One is the book1 and another one is the book2. So now to initialize first 3 fields, we have used strcpy function so that we can copy these values to the respective fields as well, and this is the book ID has got initialized. Similarly for book2, we have initialized all the 4 fields with the respective values. In the print book function, this is a print book function which is taking one address of the structure variable. So that means it is taking the address of the structure variable book1. So as a result of that, the respective prototype for print book will be struct books pointer, and it is returning nothing as output argument, so its output type will be of void. So it is returning nothing, so the output type will be void, and it is taking structure variable address as input argument, so that's why the input argument data type will be struct books pointer. We know that in case of prototype declaration, this variable name is optional, so instead of writing this struct books pointer book, we could have written only struct books pointer. Okay, now see, that is the function body. Here we have defined the function body. So struct books pointer book is there. Now to access the respective fields, I cannot use the dot, that is a membership operator, because here this book is not a structure variable, but it is a structure pointer variable. To access its respective fields value, I must be using implies, that is minus greater than, implies operator. So book dot title is not applicable here, so book implies title, book implies author. In this way we could have retrieved all the 4 fields value. So let me execute the code at first, so that we can get the idea that how the outputs are coming accordingly. So we have initialized book1 and book2, and also we have printed book1 and book2 respective values, and you can find that the values are coming quite perfectly. So here instead of using book.title, we should be using here book implies title, as book is not a structure variable, but it is a structure pointer variable.
C++, the namespaces with directives.
In this program, we have defined 2 namespaces. The namespaces, the first one is the first space and the second one is the second space. In the first space, we have defined one function with this body, and in the second space, we have defined the same function with the same prototype, but the body is containing the statement like this one. So now int main, from the main function, I am calling this func, func. This particular function has been called. But if we use this namespace first space before this particular main, the function body, then in that case, let us see that what will be the output. As we have written using namespace first space, so this first space, the respective function, that is the func, this function will be called this one, and as a result of that, inside first space, that message will get printed on the screen. So if we change this one, if I make this one as second, if you go for the second space in that case, then we are expecting that this particular function func is supposed to get executed, and inside second space this message is getting printed on the screen on the console. So in this way we have got the idea that how this namespace is playing a very vital role in the decisive factor that which function is going to get executed when both the namespaces with the different names but having the same function prototype but with the different body as well. I think now the conception is getting clear to us.
C++, the signal function.
In this program, at first we shall register the signal sigint and the signal handler function through the signal function. So here is a signal function for us. We have called this signal function, and the first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. That means when that corresponding signal will be generated, then what is the respective activity we are going to do. So that has to be maintained or mentioned in the signal handler function. So here you see, here we are having this main function, and the main function has gone for an infinite loop, and it will go on printing going to sleep, and there is one sleep function we have called which will make the program halt for 1 second. And in this case, to have this particular function defined in this respective header file, so that's why we have included this one. Okay, now let me execute my code for the better understanding. So now when I shall execute, when I shall click on compile and run option of this dev C++, then we are finding this each 1 second we are going to get going to sleep, this message is getting displayed until I press Ctrl C from my keyboard. So if I press Ctrl C, then I'm coming out, and the last line printed was this one. But as the corresponding output screen has gone off, so that's why we could not see the output properly.
C++ class member functions.
In this program, we have defined one class known as box. The name of the class is box. Under the public scope, we have defined 3 member variables: length, breadth and height of type double, and 4 member functions. And first member function is get volume, and other member functions are setter functions, that is set length, set breadth and set height. So here we are having this member function declarations. So outside of this particular class, we are going to define the respective member function bodies. So that's why we should be mentioning that this particular member function is of the box member function. So that's why we have used this one as scope resolution operator. So get volume will just multiply this length, breadth and height, and the value will be returned. We know that length, breadth and height, all of them are of the type double. So the return argument after doing the multiplication will remain as double type. In case of set length, the input argument len of type double will be assigned to the member variable length accordingly. So BRE is getting assigned to the member variable breadth accordingly, and this height has got initialized with this input argument, that is HEI. Now in the main function, we have defined 2 objects under the class box. One is the box 1, another one is the box 2. The double volume variable has got initialized with value 0 after defining. So now we are calling all the 3 setter functions to set this length, breadth and height of the object box 1. Similarly for box 2, we have called the respective all setter functions. Now to calculate the volume from box 1, we are using the member function get volume, and the volume is the output argument, and the volume is getting printed, and then volume is equal to box2 dot get volume, and then here this volume is getting printed, and return 0 is the return value of this main function, as main function was supposed to return 1 integer. So in this way the program has been written. Now let me execute the program through the option in this IDE dev C++, compile and run. So if you run this code, we are getting this output like this one. So volume of box 1 is equal to 210, and volume of box 2 is equal to 1560 accordingly. So this volume have got calculated through the member function, that is our get volume. Okay, now let me execute the same using GNU++ compiler. So I'm going for this one. So G++ proc62.cpp -o output is A. So a.exe will get produced after doing the compilation successfully, and then we are executing the code by issuing the file name a.exe. So a is there, so volume of box 1 is 210 and volume of box 2 is equal to 1560. so you see the def C++ output and this GNU C++ compile program output, they are same. In this way we have explained how this program is getting executed. We have explained the program execution line by line.
Operator overloading in C++.
Here we have defined one class. Name of the class is box. It is having three setter functions: set length, set breadth and set height, to initialize these three member variables defined under the private scope, and they are of the type double. We have defined another function here, another member function, and which is nothing but overloading the plus operator. So it is returning a box class object as output argument, and which takes one box class object reference as input argument. So it is defining locally a box class object box. Its length, breadth and height is getting initialized by adding this implies length plus b dot length, this implies breadth plus b dot breadth, and this implies height dot b plus height. Here this is nothing but is known as this pointer, and which is referring to the current object from where this operator plus overloaded function is being called. So it is defining or referring to that object from where this operator plus overloaded function will be called, and in this way it is just adding the current object's length and this input reference object as parameter, passed as a parameter, its length, and these two length values are to be added to give the length of this locally defined object box length. So in this way we have initialized them, and at the end we are returning this box object. So that's why its output argument will be of the type box. So now here we have defined three box objects under the class box, and they are box 1, box 2, box 3, and this volume is initialized with 0 of the type double. So here we are initializing using the setter functions the length, breadth and height of box 1, and similarly also for box 2. So now box 1 dot get volume is being assigned to volume, and later this volume is getting printed. Box 2 dot get volume is being assigned to the volume variable, the same variable, and the volume is getting printed here. We know that volume we have defined under the main function of the type double initialized with 0.0. Okay, now box 3 is equal to box 1 plus box 2. So this box 1 plus box 2, here we are passing two objects with this plus operator. This particular calling, implicit calling of the overloaded function plus, and actually here we are getting the same. So it is calling this overloaded function class, overloaded function plus here. Okay, now see, so box 1 plus box 2 is now getting added, and box 3 is obtained, and then box 3 dot get volume will do the rest for us. Okay, now let me execute the code once for the better understanding. If I execute the code, I'm getting this. So 6 into 7 into 5, so we are getting this one as 210 as the required output. And when we were multiplying 13 into 12 into 10, when we are multiplying 12 into 13 into 10, we are getting the value as 1560. But when we were calculating this box 1 plus box 2, that means this 6 and 12 are getting added to decide the box 3 length. So 18 will be there, 7 plus 13, 20 will be for the box 3 breadth, and 5 plus 10, 15 will be the box 3 height. So now when we are calculating the volume of them, actually we are multiplying 18 into 20 into 15, and we are getting the value as 5400, and thus the volume is getting printed at the end of our program. So this is the required output here. So if we execute the same program using GNU C++, so let me see that what is the output there. So G++, and here the name of the program is proc66.cpp -o. Let us suppose we are producing the output file as a.exe. So compilation is getting done, it has been completed, and A has got executed. I'm getting this required output as obtained. So we are getting the same output in GNU C++ compiled version of the program and this dev C++. Now let me write this particular line in another way. So we are writing this one as box1 dot, we can write in this one as box1 dot operator plus box2. We're getting the same output like this one. So this is actually the explicit calling of the overloaded function operator plus. This is the explicit calling of the overloaded function operator plus. So let me write the same, but here I'm just swapping this box1 and box2 object names. So we are getting the same output as we obtained previously. So we can write this one, otherwise we can write box1 plus box2, and that is the implicit calling of the overloaded function plus. Program has got compiled and output has been obtained as well. So I think now your conception is cleared what is operator overloading.